All right, so we're going to go ahead and start this particular review, which is a review of TEKS 6.5C, which is a student needs to be able to differentiate between elements and compounds on the most basic level. So what we're going to do today is similar to the M&M lab that you did back in 6th grade. You're going to have a paper clip that is represented by a specific color, and that color, of course, represents a specific element. So as we work through this representation today, we're going to use paper clips instead of elements because it's easier to bond the two paper clips than it was to bond the M&Ms. So just at first, take a good look at our colors here. Of course, green is oxygen, yellow is hydrogen, black is chlorine. You guys get the idea. So the first thing that we'll start off with is we'll start with just a simple representation of probably one of the most common compounds that you guys know about. So if we are dealing with these three paper clips, we have two yellows, which are two hydrogens, and then we have one green, and that's going to represent oxygen. So we know that we have a mixture right now of two different elements, one being green, one being yellow. However, we can bond these together, and that will give us our two H's and an O, which you guys should know as water, or H2O. Okay, so now we can consider these bonded. So that's how we're going to represent for this particular practice. So let's go ahead and go to the next one. We want to do a mixture. So if we put these two elements and take a second to identify those, we have a black one, which is going to be chlorine, and we have a red one, which is represented as sodium. So we could put these two in the same container, but if they're not chemically bonded, we just have a mixture of elements. We have to wait until we actually bond those two together. And as soon as we slip those two together, we know that they're chemically bonded now. And now we have Na, excuse me, of red, and Cl, which is our black. So we have NaCl, which is commonly known as salt. Once you bond these together now, you definitely have, you no longer have a mixture, now you have a compound because you have two different elements bonded together. Okay, so what we're going to show next is the original molecule of H2O, which is the two yellows and the green, and that's going to be in the same container as our Na and Cl. So what we have here is a molecule of H2O, which is a compound, and then we have our NaCl, which is a molecule of salt, and we just have them in the same container. Now these can be together as long as they're not chemically bonded or snapped with each other. Then we know that we just have a mixture of two different kinds of compounds. All right, so we're going to go a little bit farther into this. What if we have two of the same color? Take a second to identify these paper clips. Hopefully you came up with oxygen there. Those are green. And if you have two of these just kind of hanging out in the same container, these are just elements. They're not bonded together right now. Now they have the ability to be bonded together, but represented right now, they're just individual elements, single atoms of oxygen. So if we take and put these together, we have bonded those together. Right? Now what we have is two atoms of the same element. So it's not a compound because we just have two atoms of oxygen. It is, however, a molecule. A molecule, by definition, is more than one atom that's bonded to another atom. Now, you can bond to the same ones like we did in this particular representation. So we just want to make sure that you're clear on understanding the difference between a single individual atom, which would be like this, two atoms of oxygen, and then we can bond those two together, of course, which will give us O2. Now we have a molecule of oxygen. However, be aware, this is not a molecule. This is just a single atom, a single element represented by a couple of different atoms. Okay. So the next thing that we're going to show you is we'll go back, take a second to identify this particular representation is going to be 4 green paper clips, which is oxygen, and then we'll throw this one out there. That's going to be silver, and then we'll have 2 of these yellow ones. So if you're just looking at what you have on the paper, it looks like we have 4 oxygens, 1 sulfur, and 2 hydrogens. Sitting like this in the same container, it would be a mixture. We have a bunch of different elements represented. At this point, nothing is chemically bonded together. So if we were to take and bond these together, we could take these right here and put that like that, and of course mix all these together and chemically bond those. All right, and then we'll take this last silver, which is our sulfur, and then don't forget those first two H's that we started out with. So just looking at what we have represented here, we're going to do our count, and turns out, so if we start out with the H's, we have hydrogens, we had 2 of those, all right, and then we have one of these silver ones over here, so that's going to be one of those, and then of course for our green ones, we had 4 oxygens. So if we put this into its chemical compound, we have H2SO4, which of course we know as sulfuric acid, and the easiest way to show that is by our color-coded paper clips. So at this point, what you're going to want to do is take the quiz, and if you have any, if you're unsure, you can always come back and watch this video. Take the quiz to see how you do. Take the quiz more than once if you need to see where your weaknesses are and your strengths. And good luck.